Somewhere beyond the last planet, there is a machine that stopped making sense. Not slowly. On a Tuesday in November, it began sending the same meaningless pattern over and over, and nobody on Earth could read a word of it. You cannot reach it. There is no repair mission, no spare part, no engineer who can be sent. So how do you fix something you cannot touch? The carrier was perfect. Steady, strong, exactly where it should be. What rode in on it was a pattern nobody could read. The machine was not broken in the way you would expect. It was listening the whole time. It was doing exactly what it was told. It simply could not answer. Ask it a question tonight, and the answer reaches you the day after tomorrow. That is the speed at which they had to save it, which leaves a harder question than what broke. Who was still around to fix it? The team that flies this spacecraft does not work in a great hall of monitors, the way you are probably picturing. Reporters who have been there describe rented office space on the northern edge of Pasadena, next door to a McDonald's. Reporters who have visited put the number at about 10. Most have spent more than 30 years on this one project. The machine they are flying was built to reach Jupiter, then Saturn, and not much beyond. It left Earth in September 1977, before most of the people now keeping it alive had started their careers. It is nearly 50 years later. Almost everyone who signed off on that plan has long since retired or died. Whatever you were doing in 1977, including not being born yet, this machine has been flying through all of it. And much of what they need is still on paper. Reporters who have visited describe material that went missing as the offices moved. At one point, by the account of reporters who have been inside the project, they went looking for the reason one piece of the flight software was written the way it was. They called the retired engineers one by one. Nobody could remember. The machine was still running on a decision no one left could explain. A quick word, while we are on the subject of things worth keeping. If stories told this way are why you are here, subscribing keeps them coming. What they do now, Linda Spilker describes as being like an archaeological dig. Reporters describe the project manager putting someone on the archive full-time, scanning what survived of the old manuals. One of the last people who wrote the original flight software retired in 2016 at the age of 80. He was reportedly brought back in as a consultant to pass on what he knew. So part of that memory sat with one retired engineer they could still call. So here's the shape of the problem. The fault itself was small, the kind of thing an engineer could trace on a bench in an afternoon. The bench was 24 billion kilometers away. The first thing they had to work out, before anything else, was which part of the machine had gone quiet. Because the spacecraft is not one computer. It is 3 systems, each with a backup. 2 of them do what you would expect. One takes orders from Earth and carries them out. One keeps the antenna aimed at us, which is what makes any of this a conversation rather than a broadcast into the dark. The third has the least glamorous job on board. It takes everything the instruments measure and everything the spacecraft knows about its own health and packs it into a stream that a radio can carry. If that one computer cannot do its job, everything else the spacecraft knows stays locked inside it, measured and useless. That is the part that broke, which means the spacecraft never stopped talking to us. It stopped being able to say anything. So why not simply fix it? Start with what that computer actually is. It is a computer with about 16,000 bytes of memory. Everything the spacecraft measures and everything it knows about itself has to be arranged inside that space before it can be spoken. Add up all 6 computers on board, the working ones and their backups, and the whole spacecraft thinks inside less memory than a single photograph on the phone in your pocket. And not even in one piece, no computer can reach into another's. The comparison only holds for size. That photograph is stored and forgotten. This is the room the machine has to think in. The software is assembly language, written directly against the hardware, with no operating system underneath it. On a modern computer, something catches your mistakes. Here, nothing catches you if you fall. And the instruction set has no multiply, no divide. If the spacecraft needs to multiply two numbers, it adds over and over until it gets there. Now the harder part. There is a copy of the electronics on the ground, but nothing on Earth has spent 46 years out there. The only machine that could tell them how the fix would land, in the end, was the one they were trying to fix. The compilers that turned this software into machine code are reportedly gone as well, lost along with the people who ran them. So when engineers write a patch today, they translate it by hand, into hexadecimal, into binary, checking every address themselves before it goes anywhere near a transmitter. And every single attempt costs 2 days. You write the command. It leaves Earth and travels for 22.5 hours. The spacecraft does whatever you told it to do. Then the answer takes another 22.5 hours to come home. 5 months at that pace comes out to fewer than 100 exchanges. Fewer than 100 chances to ask the wrong question, and just as many waits to find out. That is the tempo the rest of this story runs at. Through the winter of 2023 and into 2024, they ruled things out. The antenna, the transmitter, the command path. Everything they eliminated made the problems smaller and the options fewer. By the time they sent the next command, on the 1st of March, there was nothing left to eliminate. What remained was inside that computer itself, and they could not see in. What they sent, on the 1st of March, was not really a fix. It was closer to a nudge. Run your software a different way. Take another path through yourself, and see what comes out. The engineers gave it a name that tells you how much they expected. They called it a poke. Then they waited the 2 days. And what came back looked, at first, exactly like what had been coming back since November. Except one engineer, working with the ground stations, noticed that a section of that stream was different from all the rest. Not readable. Just not the same. It took a week to decode. And when it finally came together, it was the entire contents of the broken computer's memory. The nudge had not fixed anything. It had done something better. It had made the machine hand over its own medical records. On Earth, there were still copies of what that memory was supposed to look like. So now there were two versions of the same mind, and a difference to find. About 3% of it was wrong. Not scattered randomly, the way noise would be. One region, failing the same way every time, the signature of a single chip that had stopped working. 3%. That, in the end, is what it took to make the most distant object human beings have ever made impossible to understand, because of what was stored there. Not measurements, not data, instructions, part of the code that told the computer how to package everything else. And nobody knows why that chip died. NASA gives two possibilities and does not choose between them. A high-energy particle out of interstellar space may have hit it, or it simply wore out after 46 years. We may never find out which. Either way, the chip was gone, and it was not coming back, which left the team with a problem that had no obvious shape. You cannot replace a chip you cannot reach, but the code that lived on it still existed because they had a copy on Earth. It just had nowhere to live. So the plan became simple to describe and brutal to execute. Move it. put those instructions somewhere else in the memory and let the computer find them there instead. Then they measured the free space that was left. And there was not one empty stretch anywhere in that memory large enough to hold it in a single piece. So they cut the code apart. They broke it into fragments small enough to fit the gaps that were left, scattered them across the memory, and rewrote every internal reference by hand. When they were done, the program no longer sat in one place. It lived in the spaces around the damage. That laboratory copy could check the logic. It could not check the one thing that mattered, which was whether the spacecraft itself would accept the rewrite. That answer only existed out there. And for 2 days, they would not know if it had worked. One wrong address could have cost them the voice for good. They did not try to move all of it at once. They started with the smaller half of the problem, the code that packages the spacecraft's own health data. Not the science. Not the reason the mission exists. Just the part that lets the machine say how it is feeling. On the 18th of April, they sent it. And then, the only thing left to do was the thing they had been doing since November. Wait. Think about what those 45 hours are like. The command has left. It is somewhere out past the planets, moving at the speed of light and still not there yet. You cannot recall it. You cannot check on it. You can only sit with the version of the future you have already chosen. On the 20th of April, the signal came back readable. For the first time in 5 months, the spacecraft told them how it was. Temperatures, voltages, the state of its own systems, all of it in plain sentences. The room in Pasadena reacted the way rooms do. People who had spent 30 years on one machine and had almost lost it found out it was still theirs. But health data is not science. The instruments were still not sending anything back, and that was the harder half of the code. It took another month. On the 19th of May, they sent the second patch, and 2 of the 4 working instruments came straight back online. The other 2 needed more work. And on the 13th of June, out where nothing else of ours has ever been, all 4 were measuring again. Magnetic fields, plasma waves, and particles, and sending the results home. It had stopped making sense 7 months earlier. Now a computer older than most of the people watching this, and older than the phone in your hand, was doing its job again, repaired almost entirely by people who never touched it. And there's one more piece of that summer, which is the part I keep coming back to. For most of the mission's life, that job belonged to Edward Stone. He took it in 1972, 5 years before launch, and kept it for 50 years. Every planet this spacecraft passed, he was there for it. He died on the 9th of June, 2024. By then, the spacecraft was already back. The engineering data had been flowing for 7 weeks, and 2 of the science instruments had come back online 3 weeks before he died. 50 years on one project. If you are somewhere in your 30s tonight, that is your entire working life, given to a single machine that is still out there. Which brings us to the part of this story that is still happening. Because everything you have just heard was 2 years ago. The people who were left kept flying it. And the thing they were flying, quietly and all the time, was running out of the one resource nobody can resupply. It loses about 4 watts every year. Not because anything is wrong, because that is what plutonium does. Which means the whole mission is now a long negotiation about what to switch off, and when, and in what order. They started switching things off. The cosmic ray detector went first in February 2025. A little over a year later, the low-energy particle experiment followed. Neither of them was broken. Both were working perfectly. There was simply no longer enough power to keep them running. The mission manager said the quiet part out loud when they made that call. While shutting down a science instrument is not anybody's preference, it is the best option available. 2 instruments are still running, and both of them listen rather than look. A magnetometer, reading the magnetic field of interstellar space, and a plasma wave detector. The spacecraft that once sent us photographs now only hears. And it is worth being precise about where it is doing that, because this is the detail almost every headline gets wrong. In 2012, it crossed the heliopause, the boundary where the wind blowing off the sun finally stops and the material between the stars takes over. That is interstellar space, and it is a real border. But it has not left the solar system. The sun's gravity still holds a vast shell of frozen debris far beyond it. Voyager will need about 300 years just to reach the inner edge of that shell, and 30,000 to pass through it. And there is a detail in that shutdown I cannot stop thinking about. When they switched the particle instrument off, they left one small part of it powered. Its scanning motor, 1/2 watt. Not enough to do anything, just enough that if the power situation ever improves, the instrument can be woken up instead of being dead. 1/2 watt of hope on a spacecraft that has been losing power since the year it launched. That is the kind of decision this team makes. Power is not the only thing running out. There is a slower problem, and nobody has found a way to stop it. It is chemical. The spacecraft holds itself pointed at Earth with small thrusters. Over decades, residue from the fuel system has been narrowing the tubes that feed them, from 1/4 of a millimeter down to about 35 microns. Pull a single hair from your head and split it down the middle. That is roughly the opening that is left. And unlike a hair, there is no way to clean it out. When those tubes close completely, the antenna drifts and everything else stops mattering. So in 2025, the team did something they had not done in 21 years. They went back to a pair of thrusters that had been written off as dead in 2004 and asked whether dead had ever been the right word. But going back to them was not safe. If the spacecraft's star tracker drifted while they worked, the cold thrusters would fire on their own, and firing them cold could have destroyed them. They worked out that a circuit switch had probably been flipped by accident all those years ago. They reset it. The heaters came back on, and the thrusters fired. The propulsion lead described the moment plainly. "It was such a glorious moment," he said. Team morale was very high that day. These thrusters were considered dead, and they are not finished trying. There is one more idea on the table, and its nickname is not modest. They call it the Big Bang. NASA describes it as a coordinated power-saving operation. Doing that on a half-century-old spacecraft, where a command takes almost a day to arrive and 2 days to hear anything back, is not a small decision. They tried it on Voyager 2. NASA reported in August 2026 that they had run it on Voyager 2, the twin. It worked. It freed up enough electricity to keep 3 instruments running for at least another year. The same procedure is planned for Voyager 1. Whoever writes those commands will reportedly be doing it the way the last team did, by hand. There is also a date coming that nobody has to work for. It arrives on its own. The date is already on the calendar. On the 18th of November 2026, at 16 minutes past 2 in the morning California time, the distance stops being a number of kilometers. Voyager 1 becomes exactly 1 light day away. For the first time, how far something we built has gone is measured in days. 1 light day means this: send it a command on Monday morning, and the command is still traveling on Monday night. On Tuesday morning, it arrives. You hear back on Wednesday. Nothing built by human beings has ever been that far away. Its own twin, Voyager 2, is the second farthest, and it is still billions of kilometers behind. And when a dish is pointed at it, a signal from it is arriving, not a recording. A live measurement of the magnetic field between the stars, close to a full day old, landing on a receiver on this planet. And it will cross that line while it is still alive, still transmitting. Still, because of 5 months of work in a rented office in Pasadena, able to answer. It will not stay that way. NASA projects that sometime in the 2030s, the power will fall below what the last instrument needs. The basic engineering signal may keep coming for a few years, and then it stops. And this is a spacecraft that has quietly outlived every schedule written for it, starting with the first one. But when it does go quiet, nothing dramatic will happen out there. It will keep moving in the same direction, in a straight line, in the dark, long after you and everyone watching tonight are gone. Somewhere above you right now, past everything with a name, there is a machine running on a few hundred watts and losing about 4 of them every year, still telling us what it finds. For 5 months, that last part would not have been true. It heard everything we said and had no way to answer, and 10 people in a rented office refused to accept that as the ending. They did not repair the broken part. It is still broken, and it always will be. What they repaired was the conversation. Bruce Wagner, who runs mission assurance for the Voyagers, put it this way. In the last decade, he has learned from Voyager that there is almost always a way around a problem, no matter how dire it is. The patch they wrote is still running. Every measurement that arrives now passes through code assembled in a rented office, for a machine almost nobody working there has ever touched. And we still do not know what killed the chip it was written for. I find that oddly comforting. One of the most closely watched objects we have ever built, and there is still something about it that we are honest enough, even now, to admit we do not know. If you have a view on that one, the particle or the years, leave it below. It is the rare question where a guess is as good as anyone's. It is heading toward the constellation Ophiuchus, and nothing out there will turn it aside. Long after the last signal, it keeps going in that direction. This was the second signal in a series about machines and the messages they send us. The first one ended with a spacecraft flying deliberately into Saturn. If you have not seen that one, it is the natural place to go next. Somewhere out there, the next story is already unfolding.